The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show. Karen, what cool project are we doing this week?
So do you remember a few months ago when the Raspberry Pi Zero came out and everyone was all excited about it, and then they all sold out really fast and we decided to not do a build because we'd be afraid that no one would be able to get one so they could build it themselves at home?
I do remember.
Well, our wonderful community out there finally broke us down and we're gonna do a Raspberry Pi Zero project.
Well, that sounds cool. What I like about the Raspberry Pi Zero is that it's, well, quite small, and also it's all surface mount. There's no through hole, so you don't have to desolder anything. It's already as small and compact as possible. So yeah, I think what we should do, since people love Pis and portables, is try to make the smallest possible Raspberry Pi device that we can.
Sweet, like a computer maybe?
Yeah, here's what I think we should do. So the Pi Zero is, as you mentioned, kind of like a stick of gum, like that. And it uses a micro SD card, which is cool. So it's quite small. So we have some LCD screens laying around.
Okay.
They're NTSC, not digital. We've used that Adafruit screen in the past. You've probably seen it. Felix has like 20 of them for some reason. That screen's pretty cool, but it's actually a little bulky, right? It's got a little bit of girth to it, and it also has a touchscreen layer, which adds more thickness. So what I'd like to do is use one of those, actually the same screen we used on the, what was it, the Atari Portable? What I like about that screen is it's quite thin, and the PCB layer is a separate layer like that, so we can move it around. So what I think we could do is we could have the screen like here. That's not really the right aspect ratio, but whatever. And then we could make something that opens up kind of like, you remember the Game Boy SP where it opened up like a clamshell? Yeah, we could make this open up like a clamshell. So,
So the keyboard will be in the bottom half?
Yeah, and since this is gonna be so small, I think we're gonna have to make our own keyboard.
Okay.
But Felix and I have done that before, so that shouldn't be a problem. So what we can do is we can take this, have the ribbon cable come down, put the driver board in the bottom half actually, like that. Put the Raspberry Pi Zero there.
Okay.
Put
And
a battery, yep, put a
yes.
battery here, and then a charge circuit we could kind of put there, right?
Cool.
Yeah, and then as far as the keyboard goes, we can measure a few of these things and get a basic idea. I think it's probably gonna be about 5 by 3 inches. So I think what we could do is we could make a frame like this, and put a bunch of tack switches on it, and then we can build the case around that. So we'll have like a minimum size for the keyboard. And then I can wire up a diode matrix, and then basically to address all the keys individually. And then Felix has some code left over from his Raspberry Pi calculator.
Cool.
He should be able to adapt that and turn it into a full-fledged keyboard. And then we'll add there'll be a USB access, USB charge, headphone jack, and power switch. So yeah, I think we should build that.
That's gonna be awesome.
Let's get started.
Amazing hacks.
Where are my dragons?
Inspired designs.
Oh, like I knocked some hot glue loose.
Regrettable acting.
I want to live in a world with Star Wars again!
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
To start this project, I'm laser cutting a grid of 13 by 5 square holes that will allow the tack switches to be placed in this engraving plastic. I'm also cutting a stiffener portion for the back to hold the buttons in place, along with access holes to allow us to solder to them. All right, so I cut 2 frames for the tack switches. The top frame holds the switch in place, and the bottom frame, in theory, will allow us to put a diode on. If we want this matrix to work well, we need a diode on every switch, which sounds like a lot of pain to wire, but what I realize we can do is we can put the diode right behind the tack switch across the leads like this. But one problem with this is if we put this frame on, I don't know, it's just kind of too deep, I think. I mean, it will definitely eat up the distance of the diode, but I don't think we can get the soldering iron tip in there. So maybe what I should do is make another frame. So this, we could have this as a jig, but then we could have a front frame which would have the cutout holes for the switches. So when you put them together, it would hold it nicely in place and nicely level. So I could do all the wiring in the back of it like this, you know, just like that, and do the matrixing, and then not even use this. That would also make it thinner. Time to cut another jig, and then hopefully I can get started with the wiring. I need to add a diode onto every switch to make the buttons isolated from each other in the matrix. I'm going to use gray wires for the columns and black wires for the rows. It's time to get wiring. Oh good, the columns are done. And now the rows are done as well. Okay, I finished wiring up the switch matrix. So we have the rows or the sense lines going across, and that's going into the diodes. And then we have the columns or the drivers going vertically. So what happens is when you push a button, it will complete a circuit between the sense rows and the drive columns. So when a column is inactive, it'll be 1. So most of them will be 1. But whatever column is active will be 0. So if you push the button, it will pull down the resistor on the sense line through that 0 and then tell you that it's active. And that's why we have a diode on every switch, so that one switch won't backfeed into another. The current can only go one way. Therefore, all the buttons are individually matrixed. Yay! I was kind of worried about putting diodes on, but then I don't know why, but Felix had this huge reel of diodes from his school. So we had plenty of diodes, and I just soldered them onto the back, and it's pretty thin. This front plate is just for mating purposes, so we won't even need this. So I'm gonna put some hot glue on this and wrangle the wires, and then we'll connect it to the Raspberry Pi that Felix is configuring. Felix is wiring my switch matrix directly up to the GPIO on the Raspberry Pi Zero. By pulsing the column lines and reading the row lines, he can determine what keys are being pressed. While Felix works on the code to make the keyboard matrix readable by the I/O stream, I am working on the case design and component layout for the Raspberry Pi Zero. So we have this screen here. This is one of those really inexpensive LCD screens meant for like backup cameras. I bought this online for like $20. What I like about it is that it's really thin. We've used that Adafruit screen in the past, which interfaces very well with the Raspberry Pi, although it's kind of thick. There's a lot of stuff to it, like the LCD layer and the circuit board. This is nice and thin, so it's not gonna give us as good of a picture, but it's gonna give us other advantages. And there's a driver board for it, but Max had the idea that we could make this thing fold like the old Nintendo SP portable from like 2003. I think that's a good idea. So the layout I like to do is this. So we have the battery here, Raspberry Pi Zero goes here, and that's good because then we can get at the SD card, the HDMI, or the USB. The GPIO here will go to the keyboard that I already wired up, and then we'll put probably one of these Adafruit LiPo chargers right here. And this should all be pretty thin. So if we put the frame around it, this is a temp frame that I made really quickly with the 3D printer, it should all fit. So that's kind of how that lays out. Let's take a look at how we made that. So here is the nesting of the objects in the computer layout. We've got the driver board for the LCD, Raspberry Pi Zero, LiPo. Here's a side view. So I tried to think about how much thickness this would require, and I think we can get this in about 1/2 inch, and the screen is about 1/4. So this whole thing will be about 3/4 of an inch thick, which is pretty good when folded. That's why I wanted to use that screen. So here's the layout view. This is what it would kind of look like open. And I cross-referenced some photos to my drawings just to make sure everything was as close as possible. So one challenge here is this board. See how it's a little off center? And I want it to be here. So I'm gonna have to actually bend the ribbon cable a little bit. It's kind of hard to tell here, but like if these two lines represent the sides of it, if we just have this come straight up, see how the screen's a little off to the left? So the screen needs to be recentered a little bit, which means there'll be a slight bend in the ribbon cable, although that should be inside the case and probably not even noticeable. So what I'm gonna do next is make a 3D test print. So this is a drawing I've been working on. This has a few features so far. There are mounting screws, and then this is where the Raspberry Pi Zero is going to sit. Here's an indent for the ribbon cable right there. And yeah, this is pretty much the base of the unit. I also have to think about a hinge. At some point I have to draw a custom hinge and put this between the sides, but you know, I'm just making one piece at a time. So next I'm going to make another print out of this, which is coming right now, make sure it works, then do another iteration on the computer here and just see how far I can get. And you know, Felix is over there working on the buttons, so basically, you know, I just have to get the case figured out. But if the case works and the battery charger works and the buttons work, then the whole thing should work. I 3D printed a couple of examples to help me design the case. This is the lid that's going to hold the screen. I also printed a partial hinge for it just to make sure it was going to work. I think it will. Ta-da, right? So I'm designing more of the base now. I have all the components. So this is going to go here. This is going to go here. There we go. This is the charge circuit. It's going to go upside down there. A place for everything and everything in its place. What I'm doing now is I'm drawing it in 2D and then I'm bringing it over to 3D, as I tend to do. I'm kind of drawing everything twice, but I don't know, it's just how I do it. So here's the 3D view. I'm starting to put in the extrusions. This is what will hold the charge circuit, and then we have spaces here for the charge jack, the USB data jack, and the SD card slot. This is where the Pi is going to go. The last thing I want to add are 2 mounting points for the LCD's controller board. So once I do that, then I should be able to start extruding the base and start 3D printing it. So the base is going to be in 2 halves. There's the bottom, which is the part I'm working on right now, and then there's the top. The top is basically just going to be a frame that has the hinges attached to it. And that's why we have the screw holes, so basically you can take it apart. Again, you always have to make something you can take apart. Yeah, so I'm just going to continue adding some holes and extruding it, and then we can begin 3D printing the case. So a while back, we created this hand-soldered Atari portable unit. And we got it working, but it had a few deficiencies. One, we didn't get the sound amplifier wired in time for the episode. And the other deficiency was the 500C battery charger that we put in it wasn't working properly. It couldn't power the unit, and also it discharged rapidly. But now we fixed both those things. I'm surrounded by robots! I am explode. Oh good, he can't fire again until the bullet goes off the screen because there's not enough memory for more than one bullet.
So if you'd like a chance to win this fancy Atari 2600 portable, go in the Element 14 community and answer our simple question about video games for your chance to win.
Okay, so I am gluing this front panel to the top half of the bottom of this panel. I 3D printed this in a couple pieces because some of the features go up and some of the features go down, specifically the hinges. So the hinges go up, see those 2 little hinges there? But there's other features that go down, such as these concavities for switches and USB ports. It would have been difficult to print everything as one piece, so I actually separated it on purpose so I could print it in 2 pieces and have more options. So this piece printed in the orientation that I'm holding it right now, basically up from here. But this piece needs to go down from there. See how the hinges go over it? So how would I have printed that? So the solution was to print them in 2 pieces. So the first thing I designed on this project was the keyboard matrix. And I kind of made it a generic rectangle, and that kind of drove everything else, like the main size of the unit, the thickness. So what I'm going to do is I'm going to get this assembled, then build the keyboard into it, and then I can add other things to it. But one negative with printing this in 2 pieces is that you have a little bit of error, and they don't mate up quite as well as other things do. So I'm going to have to do a few little tweaks here. You know, 3D prints tend to like flange out a little bit at the bottom because of the sticky first layer. And if they don't do that, then the layer doesn't stick and you don't have a part either, so kind of is unavoidable. So I need to do this and try not to cut myself or fling plastic into my eyes again. Yeah, see, if I just try to cram this in here, it'll make everything bend, which won't be good. So I have to carefully tweak it until it fits, and then we should be good. All right, so here's the keyboard. It fits in here. I need to glue it in place flush with the front before I add anything else to it. There's obviously going to be a detail layer that labels the keys. I think what I'll do is I'll use this jig again, which isn't actually going to be part of the unit, but it'll help me align everything. So I can jig it, or get jiggy with it. All right, so I'm going to glue it like this, and then I can attach this to the LCD and add the detail layer that will make the buttons look nice. I consider this unit to be in 2 parts. The top part has the LCD screen along with the hinges, which connects to the keyboard matrix. I'm making this now and attaching it as one piece, so I can then attach the matrix line by line to the bottom half of the unit later. The bottom half of the unit will contain the battery, the Raspberry Pi Zero, and the charging circuit. I also add nice details like this frame around the Raspberry Pi logo. Here's where we are. I have the keyboard and the hinge attached to the LCD. I realize though that I probably should have had these wires go down instead of up. So now I'm gonna have to re-wrangle them, but whatever, my fault, I'll deal with it. This will attach basically here. I have to let this glue set really well, otherwise the hinge is gonna crack that separate piece that I made. So the LCD board will bolt in here. Then we have a LiPo charge circuit, and that actually goes in upside down here because otherwise it wouldn't fit. Then I crammed the headphone jack in there willy-nilly, and so it does technically fit. So then we have the SD card access, charge port, and then this is the USB data port. So yeah, I'm gonna let the glue set for a while and probably resume wiring in the morning. But then, yeah, once we wire up the keyboard and these other components, we should have a working Raspberry Pi Zero portable. I've wired up the keyboard matrix to the Raspberry Pi here. I tried to keep the wires as short as possible. I'm still gonna have to bend them a little bit in order to get this thing to actually close up, but it should be close enough. So the next thing I have to do is attach this LiPo charging circuit. This one's gonna go upside down here. The battery is gonna go over here. Yeah, so got to attach this circuit to the on switch and then attach its 5-volt outputs to both the LCD driver and the Raspberry Pi Zero. But then that should be pretty much everything. A little bit more soldering and then we should be able to boot this up. Okay, quick overview of all the parts. We have the Pi Zero here, battery, LCD driver, and charging circuit, along with a headphone jack and a power switch. So I've used wire to bundle the wires going from the keyboard to the GPIO, so we should be able to get this to close. It's always important to take wire thickness into account when you're designing an enclosure like this. So it should be ready to boot. Let's see what happens. Well, the light came on, that's a good thing. Oh, there it goes. Cool, it works. Awesome. Well, I'm just gonna check a few more wires, make sure everything is where it needs to be, then I'll wrangle them, close it up, and then we can do a demo. Well, Karen, we were able to finish the super small Raspberry Pi portable, and we did it in about 2.5 days.
Ooh, that's quite impressive, Mr. Heckendorn.
Oh, thank you. So it has a 3D printed body, and then it has some laser cut panels on the inside. We have our charge port here, SD card access. This is just the USB data port. If you want to hook up like wireless or something. Here's the inside of it, look at that. And here's the keyboard that we laid out. So we had a bunch of small service mount tack switches. So we put them into a grid, wired them up. Then once we made sure that everything was wired correctly, I basically covered them with hot glue on the inside so they can't move.
Nice.
Yeah,
So can I assume that you didn't use, because I mean, these buttons are kind of small, but to use bigger ones, they probably would have been bigger on the inside as well. So you would have had to make the interior bigger.
And it would have made the size of it larger.
Yeah. It's turning on.
Yeah, this is pretty cool, right?
It's really cool.
Oh, and then I 3D printed, as part of the case, the hinges are built into the case. See how they're attached to this frame here and to here? Oh, and there's your headphone jack.
Sweet.
Yeah, all right, it's booted up. We haven't really installed much on this yet, but we can do some Linux stuff. We can like look around. Nice.
So are you worried at all about that ribbon cable getting crimped from the constantly opening and closing?
Not really, because anything, you were talking about having a slider phone earlier.
Right.
Anything that moves like that, there is a ribbon cable. They just hide it.
Okay.
But you know, we don't have enough engineering skill to hide it. As you close it, it doesn't really move a whole lot. See, it just kind of bends. It doesn't pull as much as it bends. I was a little concerned about it, but that's why I have this big wide slit for it.
Okay.
So what happens is when this thing boots up, there's a script, or well, it's not a script, it's written in C. There's a program that Felix wrote that runs when this boots up, and that program is always looking at the keys in the background, scanning them, and then when you do push a key, it inputs it into the standard I/O stream to appear as typing in Linux.
Is this Linux based? Can you type sudo?
Yeah, you can type sudo. You could type sudo into Windows if you wanted, it just wouldn't do anything.
No. Well, I mean, like, and it does something.
Do you want to try typing on it?
Okay.
All right.
With my tiny fingers?
Well, that should work better
right.
then, right? One thing I was a little worried about was the resolution of the screen, because this is an NTSC screen, not, you know, a nice digital screen, but we were able to blow it up in such a way that it's perfectly legible. So this would be also great for like a little MAME device or a gaming device, play Minecraft. And then you could always add a mouse using the external USB port. Well, that's all the time we have for today. I hope you enjoyed watching us build the Raspberry Pi Zero Portable. Have you ever built anything with the Raspberry Pi Zero? What kind of projects would you like to make with the Raspberry Pi Zero?
Let us know on the Element 14 community on element14.com/TBHS.
You can also go there to read about upcoming episodes, builds, and special events. We'll see you next time. So a while back, we created this hand-soldered Atari portable unit. And we got it working, but it had a few deficiencies. One, we didn't get the sound amplifier wired in time for the episode. And the other deficiency was the 500C battery charger that we put in it wasn't working properly. It couldn't power the unit, and also it discharged rapidly. But now we fixed both those things. I'm surrounded by robots! I am explode. Oh good, he can't fire again until the bullet goes off the screen because there's not enough memory for more than one bullet.
So if you'd like a chance to win this fancy Atari 2600 portable, go in the Element 14 community and answer our simple question about video games for your chance to win.
The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.